Is sugar really bad for your health? Sugar often gets a bad reputation, blamed for weight gain, diabetes, and cavities. But the story isn't that black and white. The truth is, sugar, in moderate amounts, is not inherently harmful to your health. The real issue lies in added sugars found in processed foods like sodas, candies, and boxed cereals. When consumed in excess, they contribute to energy surplus, obesity, and metabolic disorders. The World Health Organization, WHO, recommends that adults limit their free sugar intake to under 25 g per day, about 6 teaspoons. We use sugar every day, in coffee, baking, or simply sprinkling it over a bowl of morning fruit. But have you ever wondered where those tiny white crystals come from and how they're made? The journey of sugar is anything but simple. It's a sophisticated process, stretching from fields to factories before reaching your kitchen. Let's dive into the intricate journey of how juicy sugarcane stalks, and sometimes sugar beets, are transformed into the sweet ingredient that's become inseparable from modern life. The sweet history of sugar. Sugar is not a modern invention. Humans have known and used it since ancient times. In the 8th and 9th centuries, Arab traders brought sugarcane and cultivation techniques to Europe. Starting in Spain and Sicily. However, sugar remained a luxury item until the Industrial Revolution, which made production more efficient and sugar more affordable for the general public. Today, the global sugar industry is worth around $67 billion. Two main sources: sugarcane and sugar beets. In the US, approximately 55 to 60% of sugar is produced from sugar beets, a crop suited to temperate climates. The rest comes from sugarcane, which thrives in tropical and subtropical regions. Though both yield sucrose, they require different growing conditions and processing methods. More than just sugar. Valuable byproducts. The sugar production process doesn't just yield sugar. It also produces several valuable byproducts. Molasses, a thick, mineral-rich liquid used in rum production, animal feed, and fertilizers. Bagasse, the fibrous material left after juice extraction, often used for biofuel, paper, and particle board. Filter cake mud, a mineral-rich sludge used as organic fertilizer for cane fields. Stage 1. Cultivation and harvest. Sugarcane farming begins with planting seed canes, sections of sugarcane stems. These are grown in loose, well-drained soil with reliable water sources. The cane takes about 12-16 months to mature. When harvest season arrives, specialized machinery cuts the cane, loads it onto conveyor belts, and transfers it to trucks bound for the factory. There, the cane begins a multi-hour process to extract its sweet juice. Stage 2. Cleaning and crushing. Upon arrival at the factory, the cane is dumped onto a conveyor belt and passed through a high-pressure water system and rotating drums to remove dirt, stones, and dry leaves. Then it's chopped into smaller pieces by a crushing machine. Next, the crushed cane moves through a multi-stage mill system called a milling tandem, where large rollers squeeze the juice from the fibers. The leftover bagasse is reused as fuel to power the factory itself. Stage 3. Juice testing and purification. The extracted juice is sent to the lab to check quality, especially sugar concentration. Then it undergoes sulfitation, where SO2 gas is passed through a 10-meter-tall tower containing the juice. This kills microbes and balances the pH. Next, powdered lime dissolved in water is added to further neutralize acids and clarify the juice. This step changes the juice's color from murky brown to a light yellow. Stage 4. Settling and clarification. The clarified juice sits in tanks for a few hours so impurities can settle. The remaining sediment, or mud, is filtered to extract residual sugar and later used as fertilizer. The clean juice is transferred to an evaporation system that removes about 2/3 of its water, concentrating it into syrup with up to 65% solids. Stage 5. Sugar crystallization. The syrup is cooked again in vacuum pans until it becomes saturated with sugar. Then, tiny sucrose seed crystals are added to trigger crystallization. Once the desired crystal size is reached, the syrup crystal mixture, called massicrete, is cooled and stirred in large tanks to ensure even crystal formation. Stage 6. Separating sugar from molasses. The massicrete is fed into a centrifuge spinning at 1,200 revolutions per minute, which separates the sugar crystals from the molasses. The sugar sticks to the inner walls, while the molasses drains out. To remove leftover syrup, the sugar is rinsed with water. The result is raw sugar with a purity of 97 to 99%. Stage 7. Drying and packaging. The damp sugar is dried using hot air in a granulator until its moisture drops to 0.02%, the standard for table sugar. It's then packed into 1,000 kilograms bulk bags, which are later repacked into smaller 2 kilograms by automated machines for consumers. Sanitation and storage. A crucial factor. Even with high automation, strict sanitation is key. A small trace of fermented fiber can ruin an entire batch. To prevent this, factories use self-cleaning chutes designed to avoid buildup. Insect control and rapid post-harvest transport are essential to preserve juice quality. Raw sugar, brown or yellow, typically retains 2–5% moisture, so it must be stored in cool, moderately humid conditions to prevent hardening. Conclusion: once a rare luxury reserved for royalty, sugar is now a staple in every kitchen. Whether you're baking, sweetening coffee, or adding a touch of sweetness to your breakfast, remember, behind each spoonful is a story of advanced technology, chemistry, and human effort. After all the science, engineering, and labor, sugar arrives in your home as something simple: a candy, a cookie, a cup of milk tea. But let's not forget, each grain of sugar represents the hard work of farmers, engineers, and factory workers, and the long chain of history, culture, and innovation that brought it here.